let's review what we talked about last time. So if you have a triangle, you don't need to draw this. What do these three angles add up to? 180. Okay, that is the triangle sum theorem. Now, if it happens to be a right triangle, we had a corollary that we wrote down. You didn't use it on last night's homework, but you will, if you're smart at least, on tonight's homework. What do we know about all three of these angles? They add up to 180. And this one is 90. So what does that leave for these other two angles? Yeah, these two have to add up to 90 also. So the right triangle corollary says that these two acute angles in a right triangle are always going to be complementary. They're always going to add up to 90. Okay, we have another couple of things to do today. The first one is the equiangular triangle corollary. This says the measure of each angle of an equiangular triangle is 60, which makes sense because, well, what do the angles have to add up to? 180. And how many of them are there? 3. If you take 180 and divide it by 3, you get 60. Every one of them's got to be 60 if they're all going to be equal. So if you have an equiangular triangle, each angle has to be 60 degrees. Doesn't come up a ton, but it comes up often enough to where you want to know this. Okay? Now, the next thing we have is an idea that, excuse me, you can do an awful lot of problems without these, but two things. One is that it makes a lot of problems faster and easier, and two, there's going to be some algebra problems on these where if you don't know this theorem, you can't do the problem. It's just not possible. Okay, so it's an important idea. This is the one that I find that students tend to not remember. I'm not sure why, but this is the one more students forget about this one than anything else we learn in this unit. Everything else, they're like, yeah, I got that. And this one, I'm like, okay. So here's the deal. The angles of a triangle are also called the interior angles of the triangle. Why? Because they're inside the triangle. That's the interior. The interior of a room is what's inside the room. The interior of the triangle is what's within the borders of the triangle. So in this diagram, 1, 2, and 3, they're all called interior angles. We normally don't bother to call them interior angles. We normally just call them the angles of the triangle because they have to be there. But if we extend any of the sides, and it doesn't matter in which direction, we get these angles that are outside of the triangle. Those angles are called exterior angles because they're outside of the triangle. Okay? And then there's one step further. What kind of angles are 3 and 5? Linear pair. Okay? Those are not going away anytime soon. But 5 is also related to these two angles. Now, a linear pair, the two angles have to be right next to each other. Do you remember what that's called when two angles are right next to each other? No. Not necessarily a linear pair, but just right next to each other. Adjacent. Thank you very much, sir. They're called adjacent angles. Okay, these two are adjacent because they're right next to each other. Is 1 right next to 5? Is 2 right next to 5? No. We call those angle 5's remote interior angles. So that's a new term for you, the remote interior angles. See if I can get this to work. Okay, so for example, Travis, you with us? You okay?
Yeah, I'm tired.
Okay. So remote means far away. So for example, and y'all are all way too young to remember any time before this, but if you're watching television, most of the time, when you're going to change channel, do you get up and walk across the room and change the channel? No.
If the remote's not working, I do.
If the remote's not working, you might. And there are some, there's a fair number of TVs made today now where there's no way to change the channel unless the remote is working. Okay? The remote lets you be far away from it. Okay? Once upon a time, every time you wanted to change the channel or adjust the volume, you had to get your lazy butt out of the couch, walk across the room, and turn a dial. Okay? Remote means far away. Okay? Joey, put it away. Okay? But I don't want a distraction. So please put it away. So remote just means far away. If you go to a remote location, you're going someplace that's far away from everything else. So the remote interior angles are the ones that are inside the triangle that are far away from the original angle. So which angles are angle 4's remote interior angles? Angle 4's, yes, sir. 1 and 3, exactly right. Angle 1 and angle 3. And I'm going to show you something that's pretty cool. Please just watch for a moment. Caitlin, make up a measure for angle 1. Doesn't matter if it's super accurate, but tell me how much you think it might be. 50? Yeah, okay. That's fine. And then angle 2. Alicia's got her mouth full. I'll ask her. How much?
20.
You think angle 2 is 20? It's closer to 90 than it is to 20. We'll use 90. Okay? So if we know those two angles, can we find angle 3? Yeah. So if I add 90 and 50, that makes 140. Subtract that from 180, and then you get what? 40. Then could I find angle 5 from that? Yeah. It'd be 140, right? Because it'd be 180 minus 40. Do you notice that we had that at the very first step? If I just added these two together, I got that number. And I just asked random people to do this. Okay, let's try it again. So, Travis, give me something other than 50 for angle 1. 42. Okay. Ethan, give me something other than 90 for angle 2. 88. Okay. So let's see if it works. 88 plus 42 is 140. Let's not do 140 again. We just did 140, didn't we? So I tell you what, let's make this one 87. Just so it's at least a little bit different. So 87 and 42 is 129. So, oh, that would have been 130. We could have done that. Oh well, too late now. So if this works out, angle 5 should be 129 then, right? Yeah. Let's see if it works. 180 minus 129 is 51. And then 180 minus 51 is 129. It works. The reason it works is, notice that we subtracted 129 from 180, and then we turned around and subtracted that answer from 180. We get right back to where we were. Okay? So this exterior angle is equal to these two angles added together. That is always going to be true. It's called the exterior angle theorem. And it says the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So in this diagram up here, angle 5 is going to be equal to angle 1 plus angle 2. Or angle 4 would be equal to angle 1 plus angle 3. If it's an algebra problem, you're going to have to know this theorem. If it's just numbers, you can do it by doing the angles of the triangle, but now there's more places where you can go wrong. Okay, and which are you better at? Are you better at adding or subtracting? Adding. Everybody is. I don't care who you are. You're better at adding than you are at subtracting. Okay, so let's do a couple of examples. For this one, we want to find the measure of angle B. Please don't tell me that it's 2x plus 3. We already know that. Occasionally I have someone who tells me that. You know, oh, it's 2x plus 3. It says it right there. That's the answer. Okay, that's not what we're asking. We want a numeric answer. Notice that this angle is an exterior angle to the triangle because it's formed by extending one of the sides of the triangle. So the exterior angle, 5x minus 60, is equal to the sum of the two remote interior angles. So 15 plus 2x plus 3. So the exterior angle is equal to the sum of the two remote interiors. Now it's just a matter of solving the algebra and then substituting back in. So you get 5x minus 60 is 2x plus 18. All right. So I'll go ahead and do both steps at once. Go ahead and subtract the 2x from both sides and add the 60 to both sides, and you get 3x is 78. Is there a question, gentlemen?
No,
Just what? Nichols?
Nicholas in my class, but he's coming now.
Okay. Yeah, he had a dentist appointment. Hey, Nicholas.
Hello.
How are you?
I'm fine.
Okay. So dividing both sides by 3, we get x is equal to 26. They asked us to find the measure of angle B. So the measure of angle B
50. No.
will be 5 times 26 minus 60. Let's see, that's 130 minus 60.
Wait. Why?
We're finding 5x minus 60 from x.
Oh, sorry, my fault. I was not paying close enough attention. So the measure of angle B will be 2 times 26 plus 3. See, that's 52 plus 3 is 55 degrees.
Yeah, I guess so.
Yeah. Okay, any questions about that? So the exterior angle is equal to the sum of the two remote interior angles. Let's go on to page 2. On a problem like this, there are 2 ways to find angle 1. There's the fast and easy way, and there's the slower, I'm more likely to make a mistake way. Right? Angle 1 is an exterior angle, so its measure is equal to the sum of these 2 angles. So I just need to take 87 plus 46. 133. Didn't even have to subtract. And again, it's one operation as opposed to 3, and it's adding. Okay, it's always easier if you'll do that. All right, then the last thing that we're doing today is something that's called the third angle corollary, which says that if two angles in one triangle are congruent to two angles in another triangle, then the third pair of angles are congruent, even if one of the triangles is way bigger than the other one. So if angle Q is congruent to angle T, and angle R is congruent to angle U, the third angle theorem tells me, well, that means that angle V and angle S have to be congruent also. Because no matter how big or how small the triangle is, the angles have to add up to 180 degrees. Okay? So, let's do an example problem. Kind of a more complicated diagram. Says find the measures of angle Y and angle R if the measure of angle Y is 7x squared and the measure of angle R is 4x squared plus 36. And you're like, I got all kinds of stuff going on here. Well, this is an example of something that we'll see occasionally where two triangles just overlap one another. When that happens, the best thing to do is to take the two overlapping triangles apart. So I'm going to draw triangle YKA, which looks about like that. And in that, the little angle here at A was marked with 1 arc, and the whole angle YKA was marked with 2. And then I'll look at triangle YAK, or excuse me, RAK. Let's cheat and use my straight line drawer. So it's the little angle at K, so that only has 1 arc on it. And it's the big angle at A, so that has 2. So I've got two triangles where two angles in the first triangle are congruent to two angles in the second triangle. So that means that the last pair of angles have to be congruent. So I know that angle Y has to be congruent to angle R. If that's true, then their measures have to be equal. So 7x squared is equal to 4x squared plus 36. Now, to solve that, we haven't done a lot with quadratics. If the only variables are squared, then we'll just move everything to one side and then take the square root. Okay? So we'll subtract 4x squared from both sides. And we get 3x squared is equal to 36. Divide both sides by 3. And I get x squared is 12. And then I'll take the square root. And I can take both the positive square root and the negative square root. This is either plus or minus the square root of 12. And yes, you need both the positive and the negative. Now, especially if I was just asking you for the x. Well, now it says, what's the measure of angle y? Well, the measure of angle y is going to be 7 times, let's use the positive square root, the square root of 12 squared. What is I don't know what the square root of 12 is. Okay? Have no idea. Somewhere between 3 and 4. That's really all I know about it. But if I take the square root of 12 and then square it, what do I get? 12. So that's 84. It should be the same for angle y, or should be angle r. So it'll be 4 times the square root of 12 squared plus 36. So it'll be 4 times 12 plus 36. It's 48 plus 36 is also 84. Any questions about that? All right, your assignment for tonight is in the book again. We have some time, so I expect you to go ahead and get started on that. I'll pass back your tests and go over any questions that you have on those.